With that, though, I'm going to hand it over to Nicholas, and he will now present his account of the full case for DC charging. Thanks, Nicholas.
Thank you very much, Christian. Yes, so today I'm going to talk about EV charging trends, and not necessarily from just an Australian perspective, but from a global perspective. We all know that there are two styles of electric vehicle charging. You can charge with AC or DC, but I'm here to make a case for an environment sometime not too far in the future where we will see only DC charging. And I know it's quite hard to imagine this at this moment, but I'm hoping that at the end of my presentation, it will be a little bit clearer to you. Before I get into my topic, let me just say a few words about Rectifier Technologies. We've been around since 1992, and we develop and manufacture high efficiency power electronics, and our products are used in many applications and industries. This obviously includes e-mobility as well, supplying to this very fast-growing market. We've got offices in 3 locations. Our main office is based in Melbourne. That's where our R&D team is. We've also got a manufacturing facility that's based in the south of Malaysia, and we've got a sales and marketing team that's based in Singapore as well. These days, I'm based in Singapore. So in e-mobility in particular, we supply to 2 segments of this market. For high power chargers, we offer high powered modules. And these modules, you can think of them as the muscle that's doing a lot of the heavy lifting of converting AC to DC. And high power chargers, as we've heard already, are used for public charging. And then there's this new space in low power DC charging that I would like to introduce to our audience today in a little bit more detail in the slides to come. Some of you may have already heard about the release of our Highbury DC announced in several articles that in Australian magazines. And we've received some pretty good market feedback for the Highbury DC. And I'll talk a little bit more about the Highbury DC product as well. But this is really, the low power DC charging is really chargers for private charging. And I'll explain that in a bit as well. So this picture here, I like very much. It's a very simplified model of what electric vehicle charging will look like in the future. It's made up of 3 categories. There's public, private, and fleet charging, and they're all DC charging only, and they're also capable of bidirectional charging. So keep that in mind. I'm not going to say much about fleet charging, but I will say this one thing, that it will be a combination of slow and fast chargers in this space. And that's why I've kept the output power here fairly wide, from 11 up to 350 kilowatts, really depending on the fleet that you're looking to run. We've heard a lot about public charging already, and we know why we need public charging. It is to enable long distance driving. And that's why you typically find the higher capacity chargers in this space, between 50 to 350 kilowatts. But today, they're already talking about even higher capacities to enable heavier vehicles to make long distance travel, like your e-trucks, for example. So for high power chargers used in public charging, Rectifier Technologies, we are developing our RT22 high powered module. And this is a 50 kilowatt module here, where you can operate these modules in parallel. So if you're looking to create a 350 kilowatt charger, for example, then you stack 7 of these RT22 units in parallel, and you get the output that you want. We've taken a lot of time to really understand what are some of the pain points in deploying high-powered chargers in the field, because there are quite a number of it, and we've heard of some of it already with grid issues, etc. So if you're starting to put more and more of these high-powered chargers in the field, you would encounter a number of things, a number of issues, including maybe grid voltage destabilization, for example. And so we've really included the reactive power control feature to make it a little bit more grid friendly. And you might even run into electromagnetic interference issues. And that's why we've made it so that it complies with Class B emissions. Now, this product is expected to be available at the end of Q2 of 2021, even though we'd like to have it a little bit earlier, but because of COVID-19 and the lockdowns, unfortunately, we're just a little bit delayed. But if you'd like to know more, about this product, please feel free to contact me. I'm going to jump back onto this slide now and spend some time on private charging, because this is where we feel low power DC will really come into play. As it is, 80% of total charging, of total electric vehicle charging is private charging. You would typically find the lower end of charges here in this space. And this space in private charging is still dominated by AC chargers. And the reason for that is because every electric vehicle is still supplied with an onboard charger. Now, your onboard chargers were very useful back when EVs were first introduced because battery capacities back then were tiny. But today, the battery capacity has grown so much that you wonder if it's still necessary to lug around this heavy and costly built-in charger in your car wherever you go, or should we remove this component and make way for newer technologies? And just to give you an idea, battery capacity has increased by at least 250% since 2012. And today you can easily get 480 kilometers on a full charge, and your average daily commute is only about 65 kilometers. So that means you can go on for a couple of days without having to recharge your car. So this means as battery capacity increases, the need for an onboard charger reduces. I'll draw from an example from the smartphone industry, and I want you to pay attention to these 4 handsets here. The one thing that they have in common is that they all don't have the headphone jack. And these meant that these manufacturers were able to increase battery capacity by at least 14%. And today everyone's doing this, but when Apple first introduced this, people thought that Apple had lost their mind. But today we've got a whole host of wireless earphones that you can pair with your smartphones that have got no headphone jack. And so I think we can learn something from this, from the smartphone industry in this pairing. So if we look at it from the from our e-mobility perspective, if we remove the onboard charger that is not as required anymore, very useful back in the early days, but not as required today. If we remove that, supply an electric vehicle with no onboard charger and pair it with a low power DC charger, we're essentially creating a much more efficient charging link. So what is Rectifier Technologies doing about this? It's like I said, some of you may have already seen announcements about our Highbury DC charger, and this is a product that we're hoping to release by the end of 2021 as well. Again, it's a little bit delayed because of COVID-19 and some of its and the lockdowns that came with it. There will be 2 versions of this product, a bidirectional version and a non-bidirectional version. But for the purpose of this presentation, I'll just stick with the bidirectional specs here, just because V2G is so talked about these days. A couple of output powers we will supply the Highbury DC in. You can have this in 7 kilowatts or 11 kilowatts if you've got 3-phase AC to your home. We've designed this to have very high efficiency so that when you're charging, you get greater than 96%. And if you're exporting power from your car battery, you're getting more than 95% efficiency. We call this the world's slimmest bidirectional DC charger because it's got a depth of only 123 millimeters, and there's no other bidirectional DC charger out there that's got a slimmer form factor. We've designed this very carefully so that it's ideal for wall mounting in tight spaces so that it doesn't protrude too much from your wall to take up useful space in your garage or your carport. It will come with the standard charge plugs as well, ChargeMO or CCS, but we will release the ChargeMO version first, just because with ChargeMO and bidirectional is just a little bit more mature. In fact, the only cars that can charge bidirectionally, that can do bidirectional charging are ChargeMO ones. But as soon as CCS is available, we will make that available to the market as well. So it's just a matter of time. I will end with this slide to summarize what I've just said. Public charging, we have heard a lot about it. We know that this is a DC domain, so there's nothing that really needs to change here. The only thing is we will see, the only thing that we will notice in this space is that it will become bigger DC as we try to cater for even larger vehicles to make long distance travel. And the space that we are seeing, that we are expecting most change is really in private charging, which is now still dominated by AC charging, but we feel not for long. This is where we feel low power DC will come in eventually to displace as the onboard charger is removed from the car. And I think EV makers are already thinking about life without an onboard charger. So I hope this makes sense, why we see DC as the future charging approach, DC only, no AC and DC. Thank you very much.
Thank you, Nicholas. Super exciting to hear about some of the technologies that you're coming out with. And I'll certainly be keeping close attention to some of those developments. And so thank you